My name is Janos and I will talk about benchmark MOLA LiDAR odometry to HDMapping. So let's make a deep dive into this link. Hint, we change the branch to our favorite one. So we have a simplified instruction. Let's download the data. Data is already downloaded, so let's convert with this tool. So what we have we already clone it, we build the Docker, so let's go there. So we are here, then we can go to the data. Data is already and we already copied this one, so let's make this. So we expect that we have this file prepared. It is changing some representation of the data in the file, so it's essential. Okay, let's back to our project. So we talk about MOLA LiDAR odometry, so let's take a look where to find information about it. We have it here, and we have MOLA LiDAR odometry link here, so you can find most significant information here. You can see that it's very promising tool, very well documented. Okay, so let's back to our topic. So let's find again the instruction. Okay, so where is MOLA here? We go again to our favorite branch, and we have to prepare Docker for this experiment. So we clone our branch, then we go to our folder, then we check out our favorite branch, then we initialize everything, and then we build Docker. You can see a lot of dependencies, so it is a lot of work, should work very good. So now we convert data, so we can continue. You can see always this data problem, conversions and so on. It should be standardized, but it's not yet. So we convert data. We can close the terminal. This one also. This is Kazan, so I will not close it. Now we open terminal and we run experiment, and during the experiment I can tell you something more about the data and the project and so on. So let's make a step 4, run Docker. We change some accesses to the files, we go to the data, and then we run our experiment. So let's hope first of all, and okay. Let's hope. Okay, data appeared, so let's wait for the results, and I will tell you something about the data, from where we have this data. So if you go to HDMapping again, you can see that this website is organized and structured that it is very easy to navigate. I did it for me, so because if you make a lot of experiments, you have to have one good place that you concatenate all information. So shortly speaking, our experiments, our goal of experiments is to create some end-to-end solution for mobile mapping. Shortly speaking, let's go. So let's talk about goal. So our mission about goal is to find, develop, discover best mobile mapping framework. What we did so far, we collected plenty of open source projects, we validate them, we also wrote our own solution for the LiDAR odometry, postgraph SLAM and georeferencing. Everything is written from scratch, so it is easy to run on any operating system. We minimize dependencies, so I think this project can long last. So we can work, I hope, forever, but we will see. Now we have plenty of developers and they are putting a lot of dependencies. So if you see third parties, it is growing and it is growing like crazy. So the goal of this project to be very lightweight is not anymore sufficient for this. I will try to write a lightweight library maybe in future. Okay, so let's back to our experiment. The experiment is running very well. It's very well. It's very promising. So let's take a look into the data. So the data you can find in instructions. So if you make a deep dive into the bunker dataset, then you have instruction of our bunker dataset, and if you put on the left, then you have RVs on the right, and you have dataset on the left. So it is collected by our colleagues from Royal Military Academy. Please don't forget to cite them. They created this dataset with this fantastic device. They designed it, and they collected data with the 3D LiDAR, active, passive, time of flight, and multiple inertial measurement units. So it is very nice dataset that it is also with ground truth. You can see that they provided ground truth for this dataset, so it is easy to qualitatively and quantitatively validate results later on. Authors provided also ground truth trajectory, point cloud, and so on. This dataset is very challenging since it has plenty of narrow passages and changing illumination, and I like this dataset because it is showing real nature of the deployment of the system in applications such as, for example, making layout of the buildings and so on. As a practitioner, I can tell you that once you figure out algorithm for this dataset, then you can be sure that it will work in other places. Okay, so let's back to our MOLA algorithm. So this is documentation. You can see that it works for cars, it works for everywhere. Yeah, it's crazy good stuff. The installation is very easy. Citing use cases and so on. I like this project because it is done by very major researcher, and as far as I remember, 20 years ago I was using software from his hands, so I hope this time I will also be very happy of using this. It looks very good. It looks very good. Maybe some little mismatch, but things happened. But at least the estimation of the position of the poles is rather okay. Let's wait a little for the finishing the experiment. Then we will export data and open in Cloud Compare to perform qualitative analysis. It means we take a look visually. We make a visual inspection. I like this one because instead of tables, instead of quantitative, that you can use quantitative evaluation for papers, for benchmarking and for concise results. I like qualitative, it means visual feedback, because I can see directly if it is useful or not. So this tool that we created is especially for that purpose, that it is very easy to export to point cloud, and it is very easy to see results in Cloud Compare. Okay, so I think we are almost in the end of our experiment. We are visiting the same place. You can see some small displacement, like 1.5 meter on my eye. Okay. So, what will happen now? Now it should export data. Data is exported and they are in output HDMapping MOLA, so let's find them. Output HDMapping MOLA, this one. Let's open them in our project. So our project is somewhere here, GitHub, HDMapping, build bin, multi-view TLS registration step second. So what we do, we open the session that it is exported by our tool. So we have trajectory, we can increase number of rendered points, you can see the result. Let's export to separate scans. How to do that now? I make a mistake, so I have to maybe I will add other location. No. Home. I will put to the temp, so don't worry. It is saving now local scans. I make mistake, so let's make again file, save mark scans as one global scan. Okay, so output MOLA, all LiDAR odometry.las, and now we have point cloud in our data folder. Okay, and this one we open in Cloud Compare. And we finalize the movie. Okay, so we have our result. You can see that it is quite okay. Most of the structure is okay. I don't know where it make a problem. It should be investigated, but you can see that it can somehow navigate, it can somehow localize in this environment. Okay, thank you very much for watching. See you soon.